So I'm calling this tutorial 2A because I'm still dealing with carbon storage, and in this case we're looking at carbon storage in ice. Now if you remember back to the previous tutorial, we were looking at carbon stores, carbon sinks in various forms, and oceans appeared to be the much larger store. And then it talked about permafrost. And it didn't even mention ice storage. And so I thought I'd start with ice storage and begin with this Gemma Wadham study of 2019 from Bristol School of Geographical Sciences. So according to the study that she's put together, she's suggesting that 20,000 billion tons of organic carbon is stored within the Antarctic ice sheet, and this is 10 times higher than what's thought to have been stored in the Northern Hemisphere permafrost. Now, some of this carbon is released from the glacier through meltwaters, and that feeds marine food webs. But a lot of it is trapped under pressure and frozen within the ice as solid methane hydrates. And there's a great deal of uncertainty actually in terms of understanding how that could be released. And it says down here, if we look at this quote, we have no idea how stable potential methane hydrates will be in a warming climate if ice sheets thin. There's evidence from past phases of ice sheet wastage in Europe that sub-ice sheet methane hydrate has existed and can be released rapidly if ice thins. So this carbon storage that little is known about has great potential to release huge quantities both into our atmosphere and into our ocean systems, which we can see here. There's both direct and indirect impacts of carbon release. Another thing to consider is when we look at retreating sea ice, so melting scenario, retreating sea ice, this basically leaves more space for ocean microalgae to form. And this allows for longer seabed meal times and more sinking of carbon through photosynthesis and carbon sort of skeletons, the carbonate skeletons which corals might build. So shrinking ice sheets, more ocean sinking of carbon as a consequence. And then finally, we think about permafrost. If we're thinking about carbon stored in ice, well, we saw earlier on that there's 1,600 gigatons of carbon stored in permafrost. But a thawing permafrost has a potential to release huge quantities. If we look at this here, humans have 275 petagrams of carbon left to emit to stay on the side of 2-degree threshold. But half of this could come from permafrost melt. There's great uncertainties here about where critical thresholds lie, whether we reach a tipping point where a certain amount of warming leads to a certain amount of permafrost thaw, which releases more methane and carbon into the atmosphere, which in turn increases warming and accelerates the thawing of permafrost. That's quite a possibility, but great uncertainty.